Bismillahir-Rahmanir-Rahim. In this particular video, I'm going to talk about how we can solve a dynamic capacity lot sizing problem using Excel solver. First of all, let's discuss what's the lot sizing mean. So lot sizing mean how much quantity of a particular product we should produce in a particular time period. Capacity mean we are considering a capacity constrained production system. Dynamic means that in a particular time period the demand is changing with the passage of time. So as the time move on, so the demand is changing in every particular time period. So that's why we are saying dynamic. So in a dynamic capacity scenario, we want to find out how much quantity of a particular product we should produce, or you can say how much quantity of a particular product we should order, right? So right now, how we can formulate this problem? So we can formulate this problem in an optimization problem that is basically a mixed integer linear programming model. So our objective is we want to minimize the total cost. So right now in total cost, we have considered SJ and XJT. This is basically indicating the setup cost, or you can say the ordering cost. So SJ is representing a setup cost of a particular product. XJT is a binary variable where it is indicating if it is 1. So that means we are giving the order, or you can say we have set up a machine. So if you are considering in a production environment, then it would be considered as a setup cost. Or if you are considering in an inventory scenario, that whether we are giving the order or not, so that would be considered in a you can say inventory environment perspective. So right now I am using in a production environment perspective. So SJ is basically a setup cost. Okay, XJT, so that is basically indicating whether we have set up the system for that particular product or not for the production. Plus XJ is indicating holding cost per unit, and IJT is indicating the inventory of a particular product in a time period T. So this is basically a setup cost. This is basically the inventory holding cost. So overall, we have a total cost which we want to minimize. And we have three set of constraints. The first set of constraint is called as an inventory balancing constraint. Okay, so in an inventory balancing, or you can say demand balancing constraint, means that how much inventory we should have in a particular time period of a particular product, that should be equal to the last period inventory plus production quantity of a particular product in time period T minus demand of a particular product in a time period T. So this IJT will indicate how much quantity we should store or we should have in a particular time period T. Then we have a production constraint. So PJ is representing right now the per unit time we are taking to produce a particular product J. QJT is representing the production quantity of a particular product J in time period T must be less than or equal to the capacity of the production system, and multiply by that is XJT. So this XJT is a binary variable as we have explained earlier. So that is indicating whether we are producing that product or not, or you can say whether we have given the order of that product in that particular time period or not. So this would be 1 or 0. You can say this constraint is an on-off constraint. If we are ordering or if we have set up a product in that particular time period, then this would be 1 and this constraint will be active. Or if this would be 0, so then this constraint would be off. Okay, and in the end we have a capacity constraint. In a capacity constraint, we are saying that again PJ is representing the production time we have taken in order to produce a particular product J. QJT is a production quantity. So this is indicating how much capacity we are using, and that capacity must be less than or equal to CT. And remember that right now we are considering the capacity in terms of time. Okay, mean how much time we have available. And we are indicating that how many decision variables we have. So we have 3 set of decision variable. One is XJT, that is indicating the ordering or the setup variable. Okay, IJT is indicating inventory, QJT is indicating the production quantity. So whereas XJT is a binary variable and IJT as well as QJT are the continuous variable. So that's why, because it's a mix of binary as well as continuous variable, we are saying that this math model is a mixed integer linear programming model, because all the constraints and the objective function is in a linear form. So let's solve this particular problem in an Excel. And remember that in an Excel problem, which I am considering, I am assuming that we have only a one product. So that means there is no J, right? But there is a T. So I have considered that this is a data set I have considered. So we have 12 time period, right? And then we have in that is in terms of weeks, and we have the demand in every particular week. Okay, and then we have a ordering, or you can say the setup cost, and similarly we have a carrying cost per unit. Okay, similarly we have the capacity in those time periods, and we have a initial inventory. So this is the data set which we needed. And what are the decision variable? As we have seen in our problem, so we have three decision variables. One is regarding the inventory, which is a IJT, and next we have the ordering cost, which is XJT. Okay, and this is IJT, this is XJT, and this is QJT. So these are the decision variables. So because we have considered only a single product, so that means J would not be considered as an index. Right now we are talking about IT. So that is inventory in period 1, inventory in week period 2. Similarly, we have inventory in period 3, and so on. Similarly, we have the setup variable, which is XJT, that is a binary. So one is indicating we are ordering, or you can say setup for that particular product in that particular time period or not. Similarly, this is indicating the production quantity. So first of all, we will write down these cells as empty, or you can write down zeros in the place of all these parts. And right now, the next thing is we need to write down the objective function as well as the constraint. So first of all, let's write down the objective function. So that is saying J multiplied by XJT. So right now we have Sj, that means this variables must be multiplied with the XJT. So we have calculating basically the ordering cost. So let me write down over this way, means increasing the size. Okay, so we have the ordering cost, or you can say the setup cost, that is basically indicating. So we have D3, that is basically the setup cost, or you can say ordering cost in every particular time period. And we are multiplying it with whom? That is these cells. Okay, so that is basically the overall total cost. Similarly, we are calculating the carrying cost. How we can calculate the carrying cost? That is per unit carrying cost. That is this one, these cells multiply by we have the this one. That is basically the how much inventory we are carrying. That is these cells. So we have applied the equal sum product formula. Okay, and we multiply those one for setup cost as well as the carrying cost. So these are the total costs how we can calculate setup as well as ordering cost. Similarly, we can calculate the carrying cost, or you can say the holding cost. And then in the end, in order to calculate the total cost, so we are simply applying the sum formula, and we have sum this one, that is indicating the total cost. Okay, next what we need to do, we need to apply the inventory balancing constraint. So what's the inventory balancing constraint? So that is would be equal to equal D6. So D6 right now is indicating the initial inventory. So that is this one for the time period 1, plus that is indicating the production quantity. Okay, minus demand. Okay, that is this is the demand. So this would be the first time period inventory. So right now this is indicating when we will solve optimally. Okay, so we will see that this is indicating the how much inventory or you can say we would have in time period 1. Okay, similarly, in a for next time period, how we would say inventory in the last period, which is this one, okay, plus production quantity, okay, then this is the production quantity minus demand. And after applying the second sales formula, you can simply drag and drop, or you can say just so on. So for every particular cell, so this would formula will apply. Okay, right now because this would 0, so we haven't solved optimally, but because I have already solved with the solver, so that's why you can see the answers. But right now, first of all, when you are applying, so you can write down zeros on all places. So right now you can see the maybe the just inventory values. Okay, So we will solve using the solver. The next thing is we need to apply so we have applied the first constraint. Now we are going to apply the second constraint, which is a production constraint. So for the production constraint, I'm applying the second basically constraint, that is CT, which is a capacity multiplied by XJT, which is basically a binary variable. So what is the capacity? That is basically this one. So these cells multiply by, we have the ordering cost, that is XJT. So we have done this one, that is D5, which is basically this one, which is a capacity, okay, that is CT, and XJT is basically the binary variable, that is this one. So we have multiplied this one, and you can simply drag to the right side, okay. So this formula will apply, and in the end we are applying the capacity constraint. The right hand side is equal to CT, so we are simply write down equal to these rows. So that one, this would be equal to this particular cell. Similarly, this one would be equal to corresponding this particular cell, and so on. So we have written down the capacities, okay, constraints formulas, as well as we have mentioned the decision variable cells. Right now we are going to apply the solver. As you can know that where we can find out the solver, under the data tab there is a solver. Okay, let me explain. If you are not able to see this one, so you can go to file, then you can click on options. From options you can click on add-in. In add-in you can see the Excel add-in. Go over here and make sure you have selected the solver add-in. Once you have selected that one, you can check the solver under the data tab, that is there is a solver. Okay, so now I am going to apply this math model using this Excel solver. So I am going to click solver and then set objective. So we will click down, we want to minimize the total production cost. Okay, that is basically the setup as well as the holding cost. So this one, okay, and next we are saying we want to minimize it. And what are the decision variable? So from the decision variable, we will select all the decision variables, this one, okay. So these are the decision variables. And then the first constraint we are adding, that is basically the inventory balancing constraint, that is this one. So what is the inventory balancing constraint? So we are saying the inventory in this time period. So make sure you already have applied this formula. Okay. So these are the variables which we want to find out. So these are the inventory variables, must be equal to this one. Okay. So we have already applied the formula over here, right? That this side would be equal to this one. Okay. DAT. So this is the inventory balancing constraint. Okay, next we are saying that all these variables must be integer. Okay, sorry, binary. Okay, that is 0, 1. So that's why we are saying that all these variables must be equal to, okay, so you can click binary. So this would be equal to binary. Okay, and then we are saying the third constraint, that is basically this one. So we are saying that the production quantity must be less than or equal to this one. So where we have applied the right hand side formulas. Okay, and lastly we have applied this particular formula, which is equal to this one, that is that the production quantity must be less than or equal to the capacity, that is basically this one, must be less than or equal to this one. Okay, so once we have applied this the constraint formula, then we have to click over make sure unconstrained and then LP solver. So if we click the solve button, and then you can, if you want to generate the answer report, click answer, press OK. Okay, so once you have click over there, you can see that you have find these values. Okay, so these are the decision variables and this is a total cost. Okay, so this is indicating how much inventory we should have in this particular time period and so on. So we are setting set up for that particular product, which you can say order, and this is the how much production quantity we should produce. I hope you understand. Thank you so much. See you in the next video.